Okay, so now we have seen the addressing mode. Now this is a data transfer instruction set that this a table I have made, and in this table we have divided the total instruction which is based on the data transfer instruction. We will mention here first the format is mentioned, then the example is given, then the function, that means how it will work, this will be mentioned, then which addressing mode it is on, which addressing mode it is, and the byte length it is mentioned. This is all the data transfer instruction which we have, that is mentioned, and that are example will be given, the functions will be that how it works I will show you, then the what addressing mode of this instruction is, and what is the byte length, we will discuss that. So the first one we will see, the first one, the format is mentioned MVIR, that means MVI are register, comma 8-bit data. This is the general format, general structure. MVI a register, name register will be mentioned, comma 8-bit data. Then example is what? MVI, and here we are using the register named B, comma 8-bit data. So in this case we are using 08H. This is the data. So the functions will be what? That means this 08 data will be moved to the content of the B. So that is what this is showing, that function, that this 08H is moved to the content of the B. Now which addressing mode it will be? I mentioned. So that means what? We have already said that it will be immediate addressing mode, because if I is there, that means what? This is the immediate addressing, and the data with, and this we can say that if a 8-bit data we move to the register or the memory location directly, then that means that will be the immediate addressing. So that's why addressing mode is immediate. And byte length is what? The byte length will be 2, because it is a 2-byte instruction. What I have said, that which will be the 2-byte instruction? The 2-byte instructions will be, there will be a 8-bit data present. For quick remember, we have said that for quickly, if you want to remember, then in that instruction which contains a 8-bit data, that should be the 2-byte instruction. So here 8-bit data is present, so that's why the byte length is mentioned 2. After that, the next instruction which we have, LXI. Now what is this LXI? LXI is for, works for the register pair. Now what this meaning is, it loads the specified register pair. It loads the specified register pair with the data. So that's why LXI is mentioned. LXI means the data will be loaded or specified register in the specified register. RP means register pair. So the general format will be LXI, means load the data into the register pair. So for this case we have to use the LXI command, LXI, and RP means register pair, comma a 16-bit data. This is what? This is the general format. This is the general format. So if an example we say, then the example is if we see anything MVI D comma 8050H. This 8050H is what? This is a 16-bit address or the 16-bit data. So this is what? This is a 16-bit data. And D is what? D means DE. This is a register pair. So this is what? If we the normal functions will be what? If we see the normal function, then 8050H, this data will be loaded into the DE register pair. Register pair in this case, when you will use the functions, then the first register name should be mentioned. The second register name we didn't mention there. This is the format. That's how we will write. So that's why you see we didn't mention E here. But that means what? DE and 16-bit address. To containing 16-bit address, we require a register pair. So there we have to use a register name and 8050H or like this 16-bit data if you give, then first it will understand that loading this 16-bit data, loading the 16-bit data, you should have to store it into a register pair, because only a register can store a 8-bit data. But if you want to store the 16-bit data, you have to use the register pair. So if its system sees the 16-bit data, then automatically it will transfer that the next after D what comes E. So that means there will be the register pair, and that register pair will be DE. That register pair will be DE, and this 8050H, this 16-bit data will be loaded into the DE. And what this 80, so this will be divided into two parts. 80 will be contained by D and 50 will be contained by E. That's why only 8-bit data a register can be able to accommodate. So that's why it will be divided. So the first part will go to the first register, and the second part will go to the second register. Here also I mentioned, that means immediate addressing and 16-bit data. So if any instruction contains 16-bit data, then what will be the byte length? The 3-byte length will be there. So here the byte length case, we have set 3. Then the next instruction is what? The next instruction is what? The next instruction we have, this is move RD, RS. RS means what? Source register. This is the general format. This is the general format of any instruction. RS is what? RS is the source register, and RD is what? The destination register. So the command will look like this: move a destination register name should be mentioned, comma, a source register name should be mentioned. So example, you see, move A comma B, move A comma B. That means the content of the B will be moved to the content of the A. That means the content of the B will move to the content of the A. So the functions will look like this. And here, if it is mentioned, now we have already mentioned that if it is from source register to destination register, or any register is mentioned, in that case we call that addressing mode as the register direct addressing mode. We call that as a register direct addressing mode. And what will be the byte length? If here you see no numerical value is present, no numerical value, any 8-bit data, any 16-bit data we do not have there. So that means what? It will be the 1-byte instruction, 1-byte length. Okay, clear now? Till now it is clear?
Yes,
It
sir.
is clear to everyone? Okay. Then the next is what? The next we have LDA. LDA we already know that load accumulator and a 16-bit address should be mentioned. So 16-bit address, from seeing this, we can say that the byte length will be 3 byte, because if any 16-bit data is present, that means that will be the 3 byte. So from there we can directly say it will be 3 byte. And this 16-bit address, so this 16-bit address will contain what? A memory location. So if a memory location is associated, then we can directly say this is the memory direct operation. And example is what? Let's say LDA 95008, it is mentioned 95008. So this is a memory location, 16-bit memory location is there. So that's why it is for the memory direct, and the byte length is 3. And what will be the function? The functions will be the content. Here we have used 08H. This 08H data will be moved to the accumulator. In the content of the accumulator, it will be moved. Then the fifth is what? LHLD. LHLD and a 16-bit address. This is the general format of the LHLD command. LHLD, and after that you have to mention the 16-bit address. Now what this LHLD perform? LHLD is what? It directly loads at the HL register. HL register pair. This HL is what? This HL is a register. HL register pair. So that means it will directly store H and L registers. Stores from the H and L registers. So here this general format is LHLD, and the 16-bit address should be mentioned. So example is what? Like this LHLD and a 16-bit address given. So LHLD and 16-bit address 9500H, it is mentioned. So LHLD means what? We said that load into the HL register pair. That is what it is. Function is looking like this. The function is look like this. In this HL register pair, the 9500H will be loaded. That means in this 9500H, the content that is present will be loaded into the HL register pair. So L will contain what? L will contain 9500H, and H will contain 9500H. And here also the memory is associated, memory location is associated. So that means it will be the memory direct. And a 16-bit address is present, or the 16-bit data is present. That's why its byte length is 3. Then the next instruction, that is the STA. So the format is what? STA 16-bit address. That means store. STA is what? Store into the accumulator. Store into the accumulator. So the 16-bit address or the 16-bit memory location should be there, and in that particular memory location, the data that is present will be stored into the accumulator. So the command will look like this STA, and let's say as an example we have taken the memory location address as the 9500H. So in this particular address, the data is present will be stored into the accumulator. So if we divide this, or if we say the functions will be, the functions will be what? This the type of functions will look like. And here also the memory location is present. So that means this will be memory direct, and 16-bit address. So that means 3, byte length will be 3. 16-bit address, then byte length will be 3. Then again, the instruction SHLD and a 16-bit address. So the general format is like that. So example is like that, SHLD 9500H. Let's say SHLD 9500H. So that means here also HL mentioned. HL means what? It is the register pair. So from register pair, it will directly stores from HL register pair. So that means from HL register, the content that is stored into the HL register will be stored into the 9500H memory location. So that's why here you see from HL register, the content that is present in the HL register will be loaded into the 9500H memory location. In this memory location, the content will be moved. The content or that is stored into the HL register pair will be stored into the 9500H memory location. In that memory location, that content will be loaded. So L will contain what? L. So L, the content of the L will go to the 9500H location. But the content, these are the register pair. So H is a register, L is also a register. And combining them both, the HL register pair form. So in the L, the content of the L register will go to the 9500H location. But the content of the H will go to the 9500H location. That means next locations of the L. In that next location of the L, the content of the H will go. And here also it is a memory address is specified. That means it will be the memory direct, and the our byte length, this byte length will be the 3 bytes or the 3-bit length. It will be the 3-bit length. So this is, we have SHLD. Now the next instruction for the data transfer we have is the in command. And in 8-bit input output address, 8-bit input output address. So if it is 8-bit, from here you will say how many byte will be there. If it is 8-bit, then 2, because if it is, we are saying that if 8, the thing we are discussing, that in 8-bit input output address, in 8-bit input output address. So in command performs what? In, then a 8-bit input output address is mentioned. So 8-bit is what? It is mentioned 8-bit input output address. So 8-bit, we already know, if there is 8-bit numerical value present. So if it is 8-bit numerical value present, then that means the byte length will be what? The byte length will be 2. And here 8-bit address, we do not have the sorry. So here 8-bit input output address. So that means what? That means it is of the memory direct. Address is mentioned. So if any address is mentioned, then that means what? It will be the memory direct operation. And the format of is what? In 15H. Then that means what? That means the content of the specified port. That means this 15H is a port. The 15H address of the port, that address of a port. In that address, from that address, the content will be moved to the accumulator. This is the 8-bit input output address, and it is for a port, content of the specified port. In this content of the specified port will be moved to the, here nothing is mentioned. That means it will be moved to the accumulator. So 15H, this is what? This is an input port address. This is the input output port address. So this 15H is what? This 15H is the input output port address. And the content that is present in this 15H port, this 15H port address will be moved to the accumulator. That is the command of in. And case of out, just the opposite. just the opposite of the in. That means here from the content of the accumulator, from the content that is present in the accumulator, that content will go to this specified port. That's why that means the content that is present in the accumulator will go to the content of the input output port address. So this port address, in this port address, the content will go. So the content of the accumulator will go to this 20H, this input output port address, it will go there. And here also the address is there, so it is the memory direct operation, and the byte length is what? The byte length is 2. Then move RD, M. Now this is a general format. This is a general format of a move command. MOV RD is what? The destination register. The destination register, and M is what? M is the memory mention. Now if I have already said when discussing the addressing mode, if anywhere M is mentioned, that means what? It will be the indirect addressing mode. Capital M, if it is mentioned capital M, then that means what? That instructions is on the indirect addressing mode. So that's why this is indirect. And here you see no address is there, no 16-bit data, no 8-bit data is there. So that means what? No numerical value. So if no numerical value is present, what will be the instruction? What will be the instruction if no numerical value is present? The instructions will be, the length of the instructions will be 1. And here it is move B, M. So that means the content, the HL register pair, the HL register pair is holding, this HL register pair is holding the memory. This HL register pair move, we can say this register pair is holding the address. That means holding the address of the memory, and that inside that memory location, the operand is stored. So that means this HL register pair is holding the address of the memory, and inside that address of the memory, the operand is present. This is what? That's why it is mentioned that HL register pair, then M, and from that content, it will be moved to the B register. So this is what? Indirect addressing. And it is what? The byte length will be 1. Then the next command is, which we have, the next command is move M, RS. Then RS means source. RS means what? Source. That means from source, from memory, that particular memory, the content of the memory, it will be go to the source register. So the general format is, it is the general format, and this is what the example MOV M, A. So that means this M, this memory location will be held by the HL register pair. So HL register pair will hold the memory location, and in that particular memory location, the data is stored. That particular data should be moved to the A register, and this is what here also A mentioned. Then that means it will be the indirect addressing mode, and the byte length will be what? The byte length will be 1. Now the next is what? The next is LDAX. LDAX. Now it is what? It is a register pair. Now can you say LDX? Let's say this is LDX B. The B register name is mentioned. Then what will be the byte length of it? Anyone? What will be the byte length of this instruction?
1.
Yes, the byte length of the instructions will be 1. And which type of addressing mode is it? Which type of addressing mode?
Memory direct.
Yes, it will be the memory direct. And then what is the function I am saying? That functions, I will say, it will be clear that functions is what in this LDX, what it indirectly, it is what? Yes, there is a m not mentioned. That is why this is the indirect. This is the indirectly loads to the accumulator A. It will indirectly loads to the accumulator A. Then another function is there, that is S T A X. S T A X B. This is also what? STX. It will move what? STX. STX means our STX a 16-bit address. That means it will store. It will store from the accumulator. It will store from the accumulator A, and it will do what? It will exchange H. So this is what STX. But this command, this is the hardest command, but basically this commands uses is much more. But for general purpose, I am saying for your thing that this commands, because so this commands doesn't give in the exam because these are the high level commands. But for you, I am discussing that STX. This is what? This is the accumulator. Inside the accumulator, the content of the accumulator will be moved to the, let's say, STXB we have used. So that means the content of the accumulator, will be moved to the PC register pair. X means what? This thing you should keep in mind. X means plural form. So plural form means what? Register pair. So here only B is mentioned. That means the register pair will be what? The register pair will be BC. So the content that is stored into the accumulator will be moved to the memory address, will move to the memory address pointer of the BC register. This is the for STX. And this is also, this is what? This is the indirect addressing. This is the indirect addressing because memory address pointer is used. So if memory address pointer is there, then it will be what? It will be indirect addressing mode. But the byte length will be the 1 because no numerical value is present. So the byte length will be 1. So here what means STAXB? We are mentioning STAXB. So that means store from the content of the accumulator. The content that is present in the accumulator will be moved. Now X is given, that means plural form. So B register we will take as the BC register pair. So the content that will be moved to the memory address pointer by the BC register. So to that it will move there. Then the next is what? The next is XCHG. XCHG. This is the command. And here it is only mentioned, there is no address, there is no register, memory location. We doesn't use anything with that XCHG command. Only we write XCHG. And XCHG is what? It do that exchange. It do that exchange. With whom it exchange? With the HL register pair. That means the HL register pair, here will be what operations here it will be performed, that the content of the DE register pair. The content of the DE register pair will go to the HL register pair, and or the content of the HL register pair will go to the DE register pair. Like this it will happen. Exchange EXHG. Now this is what here, which addressing mode it will be, which addressing mode it will, anyone? The last one, implicit addressing mode, because implicit addressing mode only the operation we should mention, other than that no operand which we are mentioning. So that's why this is what, this is the implicit. And byte length will be what, 1, because byte length is what, there is nothing operands on no 16-bit address, no numerical value present. So it will be what, it will be, the byte length will be 1. And the other two is what, the other two mentioned, that is SPHL. SPHL. SPHL, this is another instruction, and this instruction do what? This instruction, our same as that, what we see at EXCHG, exchange, same as that. Here also the exchange is happening, and exchange is happening between whom? The exchange is happening between SP register pair and HL register pair. The exchange is what? That means here not exchange, here mainly it will do what? SP HL, the content that is present in the HL register will be moved to the SP register. This is the thing. And it is what? It is the implicit addressing. So only you see, we are mentioning the opcode. There is no operand specified. So that means this will be implicit addressing. And the no numerical value is present. So if there is no numerical value, then that means what it is? If no numerical value is present, then it is 1 byte. And the last one is what? The last one is XTHL. This is the last one, XTHL. And here also this XTHL do is what? It, the content basically doing what? The content is basically transferring between, we are moving between this with HL register. So the content of the HL register will move to the ST, or the content of the present in this ST register pair will move to the HL register pair. This is all the 16 commands. The 16 commands are present. The 16 commands are present for our data transfer. But between these 16 commands, basically we require, mostly given that it like this total 11, this 11s are most thing use, this 11 commands. The last 5 commands which we have seen, LDX, STX, XCHG, SPHL, XTHL, they are the high level commands, but these commands are most used. The 11, total 11 commands which we see, that 11 commands are mostly used. Now this is, we have this 16 instruction, the 16 data transfer instruction, and that's how we divide them into the addressing mode, into the byte length, then the functions, how this is performing, the general format, and with the example we have discussed. Okay, so it is clear, समझ में आया सबको? समझ में आया? किसी का कोई क्वेश्चंस है?
नो सर।
ओके, तो अगर ये जो 16 है, एक चीज है कि ये कमेंट को तुम लोगों को याद रखना है। ये चीज कमेंट जो जो दिखा है, ये कमेंट को याद रखना है, इसलिए हम क्लासिफाइड करके दिखा दें। 16 जो कमेंट्स है, ये 16 कमेंट्स के अंदर ये जो फर्स्ट 11 जो कमेंट्स है, ये 11 कमेंट्स ही याद रखना, क्योंकि वो जो कमेंट्स है वो कभी नहीं देते हैं, नॉर्मली कभी नहीं देते हैं, क्योंकि वो जो है वो हाई लेवल का कमेंट्स है। बट ये 11 कमेंट्स को तुमको याद रखना चाहिए, और जैसे हम पार्ट पार्ट पे ऐसे तुम अगर पढ़ोगे ना, तो याद रहेगा कि जब हम पहले एक लिखेंगे, उसके बाद उधर से 16 बिट एड्रेस दिखे, यस 16 बिट एड्रेस मतलब उसका 3 बाइट होगा। अब इसमें देख रहे हैं कि हाँ रजिस्टर है या मेमोरी है, तो उसके बेसिस में हम एड्रेसिंग नोड स्पेसिफाइड करेंगे। देन उसको क्या काम कर रहा है, उसका बेसिस में उसका फंक्शंस को हम डिवाइड करेंगे, फंक्शंस को हम दिखाएंगे। तो ऐसे तरीके से क्या है हम लोग करेंगे तो याद अच्छा रहता है। तो ऐसे ही तुम लोग क्या करना, इसको याद रखना। ये तो गया सिर्फ डेटा ट्रांसफर इंस्ट्रक्शन। हम लोग जो नेक्स्ट क्लास है, नेक्स्ट क्लास में क्या देखेंगे, फिर एरिथमेटिक इंस्ट्रक्शन का भी, ऐसे जितने एरिथमेटिक इंस्ट्रक्शन है, देन लॉजिकल इंस्ट्रक्शंस का जितना लॉजिकल इंस्ट्रक्शन, ऐसे टोटल इंस्ट्रक्शंस जो है वो इंस्ट्रक्शंस को हम देखेंगे। नेक्स्ट क्लास में क्या है, नेक्स्ट क्लास में हम लोग एरिथमेटिक जो इंस्ट्रक्शन है, हम लोग का टोटल एरिथमेटिक इंस्ट्रक्शन, और ऐसे ही हम क्या है उस इंस्ट्रक्शन में फर्स्ट स्पेसिफाई करेंगे जनरल फॉर्मेट, उस इंस्ट्रक्शन का जनरल फॉर्मेट, देन उसके बाद एग्जाम्पल दिखाएंगे, एग्जाम्पल के बाद वो कैसे वो फंक्शंस काम करते हैं, उसके बाद एड्रेसिंग मोड जो है, एड्रेसिंग मोड कौन सा एड्रेसिंग मोड में वो इंस्ट्रक्शन पढ़ते हैं, और उसके बाद हम लोग का बाइट लेंथ, कौन सा बाइट लेंथ है वो इंस्ट्रक्शन। तो ऐसे ही डिवाइड करके जैसे हम ये दिखाए थे, सेम एज दैट हम नेक्स्ट दिन जो है एरिथमेटिक इंस्ट्रक्शंस को दिखाएंगे। और उसके बाद क्या है, एरिथमेटिक इंस्ट्रक्शंस के बाद हम लोग सेम एज दैट जो लॉजिकल इंस्ट्रक्शन है, ऐसे लॉजिकल इंस्ट्रक्शंस को दिखाएंगे। तो ऐसे ही फिर हम लोग का जो लॉजिकल इंस्ट्रक्शंस जो है, लॉजिकल इंस्ट्रक्शंस में के बाद हम लोग का जो ब्रांच, ये सब जो इंस्ट्रक्शंस है, वो सब इंस्ट्रक्शंस को हम लोग दिखाएंगे, ठीक है। और देन लास्ट जो है, लास्ट हम लोग का जो मशीन इंस्ट्रक्शंस है, मशीन इंस्ट्रक्शंस को भी हम लोग ऐसे डिस्कस करेंगे। तो ये जो है हम लोग का टोटल इंस्ट्रक्शंस का फॉर्मेट, इंस्ट्रक्शंस का एड्रेसिंग मोड, और इंस्ट्रक्शंस का बाइट लेंथ डिवीजन है। ओके, तो नेक्स्ट क्लास में ऐसे हम लोग अरिथमेटिक इंस्ट्रक्शन और ट्राई करेंगे कि लॉजिकल इंस्ट्रक्शन जो है वो दोनों को दिखाने के लिए, ठीक है। सो टुडे दिस मच, इन द नेक्स्ट क्लास we will see that. Okay, so thank you everyone. I am ending the session.
थैंक यू सर।
Okay.